A very good morning, friends. Welcome to Unacademy. कैसे हो प्यारे दोस्तों? जल्दी से सेशन लाइक कर लीजिए सब लोग एंड प्लीज कंफर्म द ऑडियो एंड वीडियो. ओके, ऑडियो वीडियो आ रहा है. ग्रेट. चलिए, ज्वाइन फास्ट ऑल ऑफ यू. स्टार्ट करते हैं जल्दी. गुड मॉर्निंग सुरेश. ऑल क्लियर. शाबाश. ओके, सो तैयार हो सब लोग? ठीक है, शाबाश. बस 1 मिनट दीजिए. गुड मॉर्निंग अमित कुमार. चलिए, लाइक कर दीजिए सेशन सारे के सारे. स्टार्ट करते हैं अब. दोस्तों, मैं आपका दोस्त ऐश्वर्य पढ़ाता हूं आपको गेट ईएससी के लिए. आई हैव डन माय एमटेक फ्रॉम आईआईटी दिल्ली एंड बीटेक फ्रॉम जामिया मिलिया इस्लामिया दिल्ली. 4 times I have qualified GATE with my best AIR 226 and I do have 6+ years of teaching experience and 2 years of industrial experience. And these are the subjects, my dear friend, which I am taking here on Unacademy official YouTube channel, Unacademy special classes, as well as on Unacademy Plus. Theory of structure, RCC, geotechnical engineering, and strength of material. And my dear friend, this is the code S10 which you have to apply before buying any Unacademy Plus subscription in order to avail 10% off. तो कोई भी अनअकैडमी प्लस सब्सक्रिप्शन लेना चाहते हो अगर आप, देन यू हैव टू प्रमोट दिस S10 code, my dear friend, in order to avail 10% off, isn't it? Now, why Unacademy Plus? So guys, you will be needing Unacademy Plus for all these features. You can access डेली लाइव क्लासेस, क्रैश कोर्सेज यहाँ पे करवाए जाते हैं, वीकली टेस्ट यहाँ होते हैं, डाउट सॉल्विंग सेशंस यहाँ लिए जाते हैं, दोनों ही भाषाओं में कोर्सेज अवेलेबल है, रैंक इंप्रूवमेंट बैचेस भी यहाँ पे होते हैं. इफ यू आर नॉट इवन सेटिस्फाइड विद दिस, in that case, my dear friend, you may even go for iconic subscription. Okay, iconic subscription के लिए भी जा सकते हो. And in iconic subscription, you will be getting all the feature of these plus, and apart from that, you would get some specialized notes and practice sheets. एक पर्सनल कोच आपके लिए असाइन होगा. आपको स्टडी पूरी प्लानिंग के साथ प्लानर बना के दिया जाएगा. स्टडी बूस्टर सेशंस यहाँ लिए जाएंगे. पर्सनलाइज्ड टेस्ट एनालिसिस आपका किया जाएगा. इन शॉर्ट, आपको पर्सनल लेवल पे बताया जाएगा कि व्हाट ऑल आर दी शॉर्टकमिंग्स इन योर स्टडीज. ओके, तो ये सारे फीचर्स, एक 1-to-1 अटेंशन, एक पर्सनल कोच, यू कैन से पर्सनल अटेंशन will also be given for those students who are going to be part of iconic subscription. Okay, so all these are the benefits. So that is the reason why do you need iconic as well as plus. Okay, and regarding the cost of this, I will discuss in the end कि and बताऊंगा कि इनके क्या क्या कॉस्ट रहेंगे. गुड मॉर्निंग शिव कुमार चौरसिया जी, अभिषेक जी, वेरी वेरी गुड मॉर्निंग. क्या हाल है दोस्त? अमित जी, गुड मॉर्निंग. तो आ जाइए सब लोग फास्ट. स्लो हो बहुत. चलो, मैं जरा गेट ईएससी अपने ऑफिशियल टेलीग्राम चैनल पे भी लिंक भेज देता हूं. आपको याद भी दिलाना पड़ता है कि आपकी क्लासेस हैं. ओके चलिए, सो अब करते हैं स्टार्ट। So this is the schedule, my dear friend, for the month of November. मैं 4-5 दिन से डिस्प्ले कर रहा हूँ, आई होप आपको याद हो गया होगा। सो रेगुलर बैच मैथ स्ट्रक्चर सर्वे एप्टीट्यूड, लेमिनार बैच स्ट्रेंथ ऑफ मटेरियल एंड इंजीनियरिंग मैकेनिक्स, रिवीजन बैच मैथ स्ट्रक्चर सोम सर्वे एप्टीट्यूड, क्रैश कोर्स में आपका चल रहा है स्ट्रेंथ ऑफ मटेरियल, ये मैं ही ले रहा हूँ। एनवायरमेंटल इंजीनियरिंग मृगांक सर, ट्रांसपोर्टेशन क्षितिज सर, बाबूलाल सर पढ़ा रहे हैं आपको आरसीसी, जियो टेक्निकल आपको पढ़ा रहे हैं प्रांजल सर, चेतन सर बीएमसी पढ़ा रहे हैं और अभिषेक सर पढ़ा रहे हैं ओपन चैनल फ्लो। और यूपीपीएससी यही क्वेश्चंस में आपको चेतन सर मिलते हैं मंडे को 2:30 to 3:30, ट्यूसडे सेम टाइमिंग मृगांक सर, वेडनेसडे सेम टाइमिंग क्षितिज सर, थर्सडे सेम टाइमिंग बाबूलाल सर एंड फ्राइडे सेम टाइमिंग मी। और इसमें मैं आपको करवाता हूँ क्वेश्चंस ऑफ जियो टेक्निकल इंजीनियरिंग। ओके, सो दिस इज आवर एमएसक्यू एमसीक्यू बैच जिसके अंदर अभी आप लोग आए हो लाइव। सो राइट नाउ माय डियर फ्रेंड्स वी आर डिस्कसिंग you can say MSQ, MCQ and NET questions on RCC and SOM, है ना। पहले मैंने सोचा था कि RCC का एक सेशन लिया करूंगा, SOM का एक सेशन लिया करूंगा, देन आफ्टर दैट आई थॉट कि मैं शफल करूंगा क्वेश्चंस को, है ना, क्योंकि गेट में तो टोटल 15 सब्जेक्ट शफल होके आएंगे, तो मैं तो 2 कर ही सकता हूँ। तो माय डियर फ्रेंड्स, whatever session I am going to take in the month of November on this RCC SOM, so I am going to shuffle questions on both the subjects, isn't it? A very good morning my dear friend सार्थक गंजारे जी, बहुत बहुत गुड मॉर्निंग आपको। चलिए, so this is going to be my approach. So RCC and SOM I am going to shuffle the questions, and in today's session my dear friend I am having total 14 questions for you. Total 14 questions for you. All questions are MSQs. MSQ means in all the questions more than one answer can be correct. In fact मिनिमम 1 आंसर ठीक होगा, 2 भी हो सकते हैं, 3 भी हो सकते हैं, चारों के चारों भी हो सकते हैं, है ना। सो दिस इज द कंसेप्ट ऑफ एमएसक्यू। फायदे क्या है एमएसक्यू के? फायदे क्या है? नो नेगेटिव मार्किंग इन गेट, नो नेगेटिव मार्किंग। ओके, तो ये हमारे फायदे हैं। नुकसान क्या रहेंगे हमारे एमएसक्यू के? नो पार्शियल मार्किंग, नो पार्शियल मार्किंग। Suppose if in a question B and C are correct, and if you have ticked only B option, then my dear friend you will not be going to get half of the allotted marks. Okay, तो आपको half of the allotted marks नहीं मिलेंगे, you would be getting 0. No negative but no partial marking as well. Okay, so your concept must be very sound in order to attempt such questions. Okay, तो इसी की प्रैक्टिस करवाने के लिए मैं आया हूं on the subject of RCC as well as on strength of material. So my dear friend, welcome once again on the MCQ session on RCC and strength of material, and I think we should start the session now. Only these much audience is there. Where are other my dear friend? 2 less, only 13. Good morning Vamsi ji. So shall we start the session? चलो आप लोग बताओ, एक बार लाइक कर दीजिए सब लोग, एंड जस्ट गिव मी द परमिशन टू स्टार्ट द सेशन। सो गाइस, शैल वी स्टार्ट फास्ट? अरे बोलो भाई। ओके ओके, Parth is saying you can play now. अरे भाई खेलने थोड़ी ना आया हूँ. चलो. So here is my question number 1. So target subjects are RCC and strength of material. So here is my question number 1. Okay. So the modulus of elasticity of the concrete is. Let me write here question number 1. हर एक क्वेश्चन से पहले मैं यहाँ लिख दूंगा. Okay. My dear friends, once again I am telling you, in today's session I have given all the questions as MSQ. There can be more than one possibilities. There can be more than one possibilities. Okay. So I am not saying that one option cannot be correct. Only one can also be correct. But I am repeating this again and again because you do not have to select the best one. You have to select the all the possible questions. Okay. So okay. Shubham is saying C, Parth is saying C, Parth. Himanshu is saying B and C both. Amit is saying only C. Ankur C and B. Abhishek C. Brish Patel B and C. Himanshu Melkani B and C. Okay. चलिए. So my dear friend, most of you are correct that the modulus of elasticity of the concrete depends upon the secant modulus as well as it is proportional to under root FCK. है ना? There are 4 types of you can say moduli based on the stress strain curve. What are those? This is initial. This is secant. Okay, this is chord and it is tangent. Okay, so out of these 4, IS code has taken secant modulus. IS code has taken secant modulus and by considering the effect of creep and all, EC has been given as 5000 under root FCK. So you can say IS code has taken secant modulus as well as EC is directly proportional to under root FCK. So both of these options are correct. Option B and option C both are correct, my dear friend. So the very correct answer जिनको पूरे मिले हैं 2 out of 2 they are Abhishek, Bridge, Ankur Aman. Yes. So you 3 of you will be getting full marks. Well done guys. Well done. चलो बाकियों का नेगेटिव नहीं है बट पॉजिटिव भी नहीं है, न्यूट्रल. सो नाउ द क्वेश्चन नंबर 2. गाइस मैं जो लोग लेट ज्वाइन किए हैं मैं उनको फिर से रूल समझा दूं. दीज आर MSQ क्वेश्चन. ओके, more than one answer, more than one option can be correct. You will be getting entire marks only if you have selected all the possible right answers. Okay, so keep this thing in your mind and try to think positively for all the options, है ना. तो हर एक ऑप्शन को पढ़ के बता लगाओ कि सही है कि नहीं, है ना. अगर ये MCQ क्वेश्चन होता ना देन मैं भी इसी को टिक लगाता, है ना. बट आई नो इट इज कवर्ड अंडर द MSQ. MSQ क्वेश्चन आपको अलग कैटेगरी में दे रखे होंगे. MSQ क्वेश्चन आप बहुत आराम से पता लगा सकते हो. All those questions in which negative marking is not there, they are either MSQ question or they are NET question, fill in the blank type question. Okay, so you can identify them easily. Okay, not an issue. Next is question number 2 on your screen, my dear friend. So which of the following statement is or are correct? Tell me. The limit state of collapse is defined as the acceptable limit of stresses in the material. The limit state is one of that ensure adequate factor of safety against collapse, and in limit state design method, actual stresses developed at collapse differ considerably from the theoretical value, and fourth option is none of the above. Okay, so select the right one, my dear friends, select the right one. So total 14 questions are there for two. और जो दोस्त मेरे बाद में आ रहे हैं उनको मैं बता दूं कि आज सोम आरसीसी ऑल आर मिक्स्ड, बोथ आर मिक्स्ड। अजय, अच्छा अजय जी का आंसर आ गया है, मैं क्वेश्चन 2 लिखना भूल गया। ओके, क्वेश्चन 2, बट अजय जी का आंसर मुझे याद रहेगा। अजय इज द फर्स्ट टू आंसर एबीसी। आई एम नॉट सेइंग वेदर इट इज करेक्ट और नॉट। Amit is saying B and C only. Okay. Bridge is also saying B and C only. चलो एक चीज तो श्योर है, दिस कैन नॉट बी करेक्ट। डी हैज बीन एलिमिनेटेड। नाउ द फाइट इज बिटवीन BC एंड ABC. Okay. Okay. Shubham is also saying ABC. My dear friend, option A is not correct. Acceptable limit of stresses, no. All the limits are at failure, so this is not correct. Okay, means here we are just ensuring that the structure is safe against the collapse. So based on that, this design is being done. Okay, and whenever my structure fails, see A और C वैसे ही contradict कर रहे हैं, A और C वैसे ही contradict कर रहे हैं. Whenever my structure is going to fail, at that point of time, the actual stresses developed at collapse differ considerably from the theoretical value. Theoretically, we are saying that at the time of collapse, stress in the concrete is 0.45 FCK. Okay, like that. But this is not the reality. This is the most upper limit. Okay, but whenever my material is failing, so it is failing below that only. It is the ultimate point where your material is going to collapse. Okay, so only option B and C are correct. Only option B and C are correct. So for this answer, Amit Kumar Das, Brij Patel and Abhishek Kushwaha will get full marks. Okay. आई थिंक मैंने ये सब सारे देख रखे हैं, टॉप चैट, लाइव चैट, ओके, लाइव चैट, ओके, शुभम, चलो। So now here is question number 3. This is from strength of material. This question is from strength of material. So let me write here question number 3. Okay. This is the interesting question. From the very beautiful concept of strength of material, which is shear force diagram as well as bending moment diagram. Okay, so what all are the things which are correct here that you have to tell me? Okay, so tell me guys, टाइम लगेगा इसको सॉल्व करने में बट मजा आएगा। तो बताइए दोस्तों जल्दी। अच्छा, टाइम भले ही ले लो, बट ट्राई टू गिव द करेक्ट आंसर एट वन इंस्टेंट। सोचो ना कितना कॉन्फिडेंस बिल्डअप होगा आपका जब एक ही बार में आप सही आंसर दोगे। So this one is particularly from strength of material. चलो टाइम हो गया भाई, सफिशिएंट टाइम दे दिया गया है। अरे कोई तो बोलो। अरे गाइस, कर भी रहे हो कि वेट ही कर रहे हो बस? ओके, ओनली वन आंसर। Okay, let me check options one by one. So first is, now see here, आवाज आ रही है ना? Okay, okay. So first is bending moment at C. So अगर C पे bending moment निकालना है, then let me draw the free body diagram of C. It is going to be like this. And here are some forces, 2 and 1. And this distance is 1.6, 1.2. This is the bending moment M. Okay. So if I'm calculating this M, then I will get minus M plus 2 into 1.6 plus 1 into 1.2 is equal to 0. So M is equal to ये हो जाएगा 2 into 1.6, 3.2 and 1.2, 4.4. Yes. Okay. Now bending moment at B is equal to 0. So bending moment अगर मुझे B पे निकालना है, so next time what can I do? अभी तक A तो सही पता चल गया मेरे को. Next time what can I do? I can draw the free body diagram of this structure at B. Okay, so this is clear to me. So next thing is B का free body diagram बनाएंगे. So it would be okay. B पे bending moment निकालना है. So it would be this system का equilibrium. देखो कट तो कहीं भी लगाओ, लेफ्ट से राइट से, you are going to get the same answer. So EDCB, EDCB. So minus M plus 2 into 0 plus 1 into 1.2 is equal to 0. So M is equal to 1.2. It is not equal to 0. So this statement is incorrect. So bending moment at A is not equal to 0. In fact, it is equal to 1.2. Is it clear? Is it clear to all my dear friends? Okay. Next is maximum bending moment in AB portion is 1.2 kilonewton meter. Okay, let's check that. Maximum bending moment. So how we can find the value of maximum bending moment? That is important to know. So this is only about you can say M. So this is how much, in order to say summation of fx is equal to 0, it is 2. Summation of fy is equal to 0, 2. Summation of fx 0 is equal to 1. Now these three forces can be carried over to this support. Okay. So these three forces can be carried over to this support. And how to find these? So this is my beam. Okay. A and B. B and A 3.2. This is B. This is A. This distance is 3/2 meter. This is anti-clockwise M. So carry over here would be, sorry, it would be 3.2. It would be 2 kilonewton. It would be 1 kilonewton. Okay. So if I want to write RA here, then RA is going to be equal to surprisingly, no one even has attempted this question. I do not know the reason. भाई attempt तो करना चाहिए था ना ये, या मेरे comments अपडेट नहीं हो रहे हैं? So RA is 12/32, 6 by 18, 3/8 है ना, 4 3 हमारा 4 8 32, ठीक है, 3/8. So this is 3/8. So 3/8 into 3.2 is how much? 1.2. So सही बात है. Maximum possible bending moment in AB is 1.2. So this statement is also correct. C is also correct. ठीक है. The shear force in AB portion is constant and is equal to 0.375. Yes. You can see here, what is shear force here? Shear force here is constant and it is equal to 3/8. So what about 3 by 8? 3 by 8 is I think 0.375. Okay. So 0.375 ही होता है ना, 3 8 8 या 24 ना, 8 6 48 8 7 56. Yes, 375 is correct. So option number A, C, D are correct and B option is not correct. है ना, थोड़ा बड़ा क्वेश्चन था. So please tell me my dear friends who all are agreeing with me. A, C, D कौन कितने लोग एग्री कर रहे हो? Tell me my dear friends. A, C, D is the right answer. Okay. Okay. चलिए. So now the next one is question number. Okay, Shubham is saying A, C, D. Okay, Govind had said A, B, C. Unfortunately, that is wrong, my dear friend. So now the next question on your screen. Question number 4 of 14. So which of the following statement is are correct? It is again from the strength of materials. I hope it is easy to answer. I hope it is easy to answer. Okay. Shubham Tiwari is saying ADB. ABD. Okay. ABD. What about others? My dear friend, participation is not up to the mark. You are around 20 numbers and I am getting response only from 1 or 2. This is not acceptable, my dear friends. Interact नहीं करोगे तो कैसे मजा आएगा? K Rahul is saying ABC. After long time K Rahul आपको देख रहा हूं मैं. Total entertainment is again ABC. Shubham Pal is saying B and C. Okay. Okay. चलो देखते हैं. If the load is passing through shear center, then there will be only bending in the cross section but not twisting. My dear friend, this is the definition of shear center. This is the definition of shear center. shear center वो होता है, वो पॉइंट होता है जिससे जब कोई भी लोड पास करे तो सिर्फ और सिर्फ वहां पे बेंडिंग हो, ट्विस्टिंग ना हो. सो लेट मी मेक यू अंडरस्टैंड दिस. ठीक है, देखो क्या होता है, लिसन टू मी. देखिए जैसे यहाँ पे मान लीजिए मेरे पास ये एक ये बीम है, ठीक है, और ये फिक्स सपोर्ट है और ये मेरे पास बीम है. ओके, so if I am going to apply load here, it will be having tendency to bending. It will be having tendency to bending. It will bend like this. Okay, it can break, isn't it? या फिर okay, जी समझो, it can break. Okay, but my dear friend, suppose this is a point load and if I'm applying here point load, then only bending can happen. But if this point load is eccentric, if it is on this side or it is on this side, then what will happen? Along with bending, twisting will also be occurring. Twisting will also be occurring. So out of these many planes, there will be one plane about which if load is applied, then there is only bending, no eccentricity with respect to other direction. So only bending, no twisting. So such a point is known as shear center, my dear friend. So shear center is defined as such a point where only bending will be there if the load is passing, but no twisting moment would be there. Okay. The plane of loading contains the bending axis. No, this is not correct. The plane of loading contains the bending axis, my dear friend. This is not correct. Why it is not correct? Listen to me. Suppose if this is your beam and you are applying load somewhere here. So let me draw the cross section here. So your bending axis is there. You have applied load here, but your bending axis is there. So this is this plane. ओके ये वाला प्लेन हो जाएगा और ये वाला प्लेन कौन सा है, इसके परपेंडिकुलर जाकर के ये एक्सिस. ओके सो दिस प्लेन इज perpendicular to the loading plane, not the same. Okay, so that is why this statement is incorrect. Is it clear? Sir, is shear center a point or line? देखो एक्चुअली शियर सेंटर आपका क्या कहते हैं, एक पूरा उसको रिप्रेजेंट करता है लाइन ऑफ एक्शन को, बिकॉज इफ फोर्स इज अप्लाइड थ्रू दैट लाइन ऑफ एक्शन, ओके, देन ट्विस्टिंग विल नॉट बी देयर. फॉर एग्जांपल इफ आई से हियर दैट इफ आई एम गोइंग टू अप्लाई हियर सम लोड, तो लोड का पूरा एक लाइन फिक्स हो गया ना, उस लाइन से मैं कहीं पे भी लोड मेरा पास करेगा तो मेरा इसेंट्रिसिटी सिस्टम में नहीं आएगा. ओके So you can say it is a line, but obviously whenever a cross section is given to you, so you have to identify a point that where twisting cannot be happen. So there are some certain formulas in order to find that. But if you are applying load on the top, then that line of action of the load must be passing through that point only. Okay. So third is I section is preferred to the rectangular section for the resisting bending moment. This is correct. This is correct. I is preferred to the rectangular. Okay, for the resisting bending moment. My dear friend, I section, due to the wide flanges, as you all know that if we are drawing the bending stress diagram, then bending stress diagram are generally having the extreme values at the outermost portions. So if outermost portions would be having wider availability of the material, then such a section would be very efficient in resisting the bending moments. So that is the reason why I sections are preferred more. Relatively, you are saving this much material here. Although there are some challenges of you can say shear stresses here, but that we can eliminate by providing some stiffening girders etc. here. Okay, and the assumption of plane cross section remain plane will not hold hood during inelastic action. Inelastic matlab plastic action. It is again incorrect. My dear friend, even in plastic analysis, we are assuming same thing that plane section before bending will remain plane after bending. तो मैं तो अपने स्टूडेंट से बोलता रहता हूं कि ये प्लेन सेक्शन बिफोर बेंडिंग विल रिमेन प्लेन आफ्टर बेंडिंग is not a SOM structure, RCC or steel assumption. It is the assumption of BTech civil. तो पूरे के पूरे BTech civil में हमारा ये थ्योरी हमेशा वैलिड रहेगा that plane section before bending will remain plane after bending. It means strain diagram is going to be linear. Okay, चलिए. So now the question number 5 of 14. ओके, शिवम एंड शुभम आर सेइंग कि सर ए बी सी पे ताला लगा लो. ओके, ए बी सी. चलो एक हिंट दे देता हूं कि डी तो नहीं है ना. डी तो नहीं है. सो नाउ आउट ऑफ ए बी सी, ए बी सी. ओके. My dear friend, I do not know why you are including C. Why minimum shear reinforcement will take care of torsion? Okay, this is not correct. For this, we have additional torsional reinforcements and all if it is required. In shallower depth for lesser deep section, torsional reinforcement is not required. So here you can say it improves the ductility of the cross section and it provides the better form of dowel action. Dowel action, you know, na? Suppose if this is a bar and if you are pulling it, then its resistance is due to this dowel action. Okay, so A and B only are correct. This torsion one is not correct. This torsion one is not correct. Yes, C will not be included. Torsion design is a different thing. Anna, we do not need the torsional reinforcement in B if its depth is less than, you can say, 350 mm. Okay, or you can 450 mm. So generally our beam are not that deep, and if it is deeper than that, in that case we have to see that what is the amount of torque acting there. Okay, scatter means take care. It is taking care of any torsional steel in that beam section. Okay, so only A and B are correct. Only A and B are correct. चलिए. Now next, question number 6 out of 14. Okay, Rahul. Take. So which of the following pair is correctly matched? So this you can consider either RCC column or column of SOM. कुछ भी मान लीजिए. But I would like it to keep under strength of material. Strength of material would be more basic. So you have to tell which all are the pairs which are correctly matched. A, B, C. Okay. Why Rahul is so happy? But literally, my dear friend, participation is not up to the level. सिर्फ 2-3 लोग ही पार्टिसिपेट कर रहे हो, ऐसा क्यों? शिवम जवाब दे रहे हैं, शुभम दे रहे हैं, राहुल जी पार्टिसिपेट कर रहे हैं, गोविंद कभी कभी कभार दे देते हैं आंसर. ओके, कहाँ गए ब्रिज जी, आदरित, अभिषेक, अमित कुमार? ओके, so tell me which of the following pair is correctly matched. A, B, C, D. Pin, pin, fixed, 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 free, fixed, fixed. Okay. देखो, this is a general expression that Euler's buckling load or crippling load is given by pi square EI upon L effective square. So here the L effective is L, which is all right for pin. Fixed में L effective होता है L/2. Okay, Bharat is also right. Fixed में L effective होता है L/2. So you can say L/2, L square by 4. 4 will go upside. Fix free मतलब ये वाला. यहाँ L effective होता है आपका 2L. So 2L whole square, 4L square. This is also absolutely correct. Fix pin. यहाँ पे L effective होता है आपका L/√2. But my dear friend, ambiguity is here. L/√2 होने के लिए there must be 2. अगर ये होता ना 2 pi square EI upon L square, in that case तो आप लिख देते कि it is pi square EI upon L/√2 का whole square. ऐसे आप लिख देते. But it is already √2. So this root is simply to confuse you guys. So this is incorrect. So all these three remaining are correct. So Rahul, Shivam और भरत मिश्रा are right for these questions, my dear friend. Okay. चलिए. Now the question number 7. Okay. देखो आप में से कुछ लोगों को मेरा सेशन स्लो भी लग सकता है. But my aim is not just to display question and proceed. Okay. So whenever I am taking any MSQ, MCQ और NET session, so मेरा कोशिश रहता है कि जो भी स्टूडेंट, एवरेज स्टूडेंट भी इसको बाद में देखे तो उसको भी कुछ ना कुछ बातें समझ में आए, है ना. So in such a way I am trying to plan my lecture. It's not about between the good learners and educator कि हाँ ये इसका आंसर है नेक्स्ट, ये इसका आंसर है नेक्स्ट. नो, इट शुड नॉट बी लाइक दैट. आप बाद में भी कभी इसको देखो तो एक दो पॉइंट्स आपको याद रहे. ये मेरी कोशिश रहती है किसी भी ऐसे सेशन लेने से पहले. So here is question number 7 on your screen, guys. Okay. माजिद भाई साहब बोल रहे हैं सर ए पे ताला लगा दो. But I think you have joined late. Majid, there can be more than one possibilities. So you have to select all the correct possibilities. It is MSQ type question. So there can be more than one answer correct. May be correct, may not be correct. So I hope while you are answering, you have considered all the options. So माजिद भाई ये बोल रहे हैं, शिवम भाई ये बोल रहे हैं, भरत मिश्रा जी कह रहे हैं सर ए बी सी तीनों पे ताला लगाओ. अजय खत्री कह रहे हैं कि सर ए सी डी पे ताला लगाओ. वाओ. Okay, what about others? Rahul is saying AC. Okay. चलो इतना बता दूं कि so far one of you is correct. अभी तक आप में से कोई एक 100% करेक्ट है. शिवम इज सेइंग सर ए डी पे चलते हैं. ओके. So far one of you is correct. Yes, Ajay Khatri. Yes, my dear friend. Ajay Khatri is right so far. A C D is the right one. A C D is the right one. A C and D. Now see why. A two-span continuous beam of equal span simply supported and loaded by UDL over both span. अच्छा, एक दो स्पैन कंटिन्यूअस है. एग्जैक्ट मैंने इसके डायग्राम तो बना के दे रखे हैं आपको स्ट्रक्चर एनालिसिस के लेक्चर्स में, बट यहाँ पे भी एक रफ स्केच ड्रॉ कर देता हूं। सो एक ल्यूडियल लगा हुआ है। सो माय डियर फ्रेंड, इफ यू आर गोइंग टू ड्रॉ इट्स कंटिन्यूस स्पैन है ना, बीएमडी, तो कुछ ऐसा बनेगा। ओके, my dear friend Rahul, probed cantilever, by default it is meaning only this one. Probed cantilever means one end is fixed and another is hinged. Okay, so by default it is like this only. Okay, अंकुर अमन जी कह रहे हैं बैड, मतलब BAD। नो अंकुर, कैड बोलते तो अच्छा लगता, कैड बोलते तो अच्छा लगता। So there are two contraflexors. There are two contraflexors. I can see here one is this and one is this. Okay. So in which of the following point of contraflexor will occur? So it is occurring in A. Okay. A simple support beam loaded by UDL. If simple support beam, my dear friend, contraflexor उसको बोलते हैं जहां पे अपना बेंडिंग मोमेंट साइन चेंज करे, जहां पे बेंडिंग मोमेंट साइन चेंज करे। Do not think that 0 is simply equal to contraflexor. Here this is not contraflexor, this is not contraflexor. Contraflexor मतलब B member sagging से hogging जाए या hogging से sagging जाए. So they are positive and negative, they are negative and positive. So two changes you can see here over this span. So two contraflexors are here, zero contraflexors are here. Now if a fixed beam is loaded with the UDL, in that case what you can do? If a fixed beam, and please do not be confused in among name. Fixed means by default it is fixed beam. Propped cantilever beams by default one side is fixed and another is hinged. Okay, cantilever beam by default mean one end is fixed and another is free. Okay, so if you are going to draw the bending moment diagram here, my dear friend, then you have to plot it like this. So here as well you can see that here as well you can see that two contraflexors are there. Two contraflexors are there. And even if you are talking about propped cantilever beam, which is again loaded with the which is again going to load with the UDL, then it is going to have one contraflexor even like this. Okay, one contraflexor. But simple supports are the support which is not having any contraflexor. So A, C, D, all three possibilities are correct. This is incorrect. Okay. I hope it is clear to you guys. Okay. So this is about question number 7. Now let's come over. In D, both ends are propped, sir. राहुल, अगर दोनों एंड प्रॉप्ड होते दोस्त तो सिंपली सपोर्टेड बीम हो जाता ना भाई। ये देखो, नेमिंग में कंफ्यूज मत करो यार, नेमिंग में यू शुड नॉट कंफ्यूज। सिंपल सपोर्ट बीम, सिंपली सपोर्टेड बीम। ओके, propped cantilever beam, cantilever, all these are basic name. Cantilever. Okay, fixed beam, fixed beam or fixed beam, both are having same meaning. Okay, continuous beam. So this is simply support. Propped cantilever means one end is fixed and another end is not free. It is propped. That is why it is propped cantilever. Cantilever is one chhajja, one is free. Fixed beam or fixed beam is both are having same meaning. Because this is cantilever, this is propped cantilever, this is simple support. So fixed beam means both sides are fixed, I am having fixity. Continuous means more than one span, here, like that. And these conditions, if it is continuous, it will be going like that. Okay, so all these are the default meanings of this name, है ना? बताओ स्ट्रक्चर बढ़ा दिया यूट्यूब पे पूरा, अभी तक ऐसी बातें कर रहे हो. Okay, so now the question number 8. Question number 8 out of 14. It is from RCC. Yes. If it is overhanging on both the sides, you have to call it overhanging beam. You have to call it overhanging beam. Okay. Then you have to call it overhanging beam. Okay. चलिए बताइए next. The bond between steel and concrete is mainly due to. It is mainly due to mechanical resistance, pure adhesive resistance, frictional resistance, or none of these. ही बॉय, मेरा कोई नाम नहीं है, क्या बात है. चलो वैसे भी जो नाम वाला है वो बदनाम है. ओके, क्या बात है, 11 बज गए हैं, 2 घंटे का सेशन है, एग्जैक्टली इंटरवल पे आ गए हम. अब 8वां क्वेश्चन. रीना इज सेइंग सी. ओके, ओके. Rahul is saying B. You can select even more than one. You can select A, B and C. Muhammad Majid is saying A, B and C. Okay. Shivaraj is saying B and C. Okay. K. Rahul is saying A, B, C. So far 2 of you are correct. So far 2 लोग ठीक है. Okay. So Muhammad Majid and K. Rahul, both of you are correct. Well done, guys. The bond between steel and concrete is basically due to all these 3 reasons. है ना? सबसे कम होता है ये एडहेसिव, फिर होता है ये फ्रिक्शन, और सबसे ज्यादा होता है मैकेनिकल रेसिस्टेंस. ओके, मैकेनिकल रेसिस्टेंस, और यू कैन से इट इज डेवलप्ड ड्यू टू द कोरुगेशन ऑफ द बार. ओके, so this is highest. So adhesive is least. It is due to the, you can say, water cement ratio, or you can say during the setting of concrete, concrete is releasing some of the fluid, so which is actually getting adhesion on the surface of steel, और उसके कारण उन दोनों के बीच में कुछ ना कुछ स्ट्रेंथ होती है. So whenever, my dear friend, your bond is going to break, so it is the first one which will lose, then friction, and then at last mechanical resistance. Okay, so well done Majid and Rahul. चलिए क्वेश्चन नंबर 9. क्वेश्चन नंबर 9. RCC. Question number 9 is again RCC. So the specified yes, mechanical resistance like in hooks. No, my dear friend. Mechanical resistance is due to corrugation. Mechanical resistance, my dear Ajay, is due to corrugations. So, see, so you are generally, whenever you are talking about HYSD bar, then you have to increase the bond strength by 60%. So that is the reason. So due to these corrugations, my dear friend, due to these corrugations, what is actually happening? This is ultimately helps in improving the mechanical resistance. Okay, चलिए आप क्वेश्चन नंबर 9 पे भी आ गए. ओके, क्वेश्चन नंबर 9 माजिद भाई बोल रहे हैं सर ए और सी पे ताला लगा दो. ओके, गुड. ओके, ए एंड सी क्वेश्चन नंबर 9. द स्पेसिफाइड स्पैन टू डेप्थ रेशियो. आवाज आ रही है ना मेरी? हेलो. Yes, it is there. Okay. The specified span to depth ratio of the beam satisfying the limit of vertical deflection for span up to 10 mm. Select the right statement. है ना, ये सही बात है. आपको याद होगा कैंटिलीवर के लिए होता है दिस रेशियो इज 7, सिंपली सपोर्टेड के लिए वी आर टेकिंग 20 एंड फॉर कंटिन्यूअस बीम वी आर टेकिंग 26. ओके ओके, यस, मैं कंफ्यूज हो गया था कि मेरा माइक म्यूट ना रह गया. ओके, थैंक्स अजय. ओके, so for higher span these are to be modified by multiplying the ratio by 10 by span in meter. सही बात है ना. अगर if my span is greater than 10 meter, if my span is greater than 10 meter, in that case we have to multiply our ratio this by 10 over span. But yes, one thing is there. It is if span is greater than 10 meter, then cantilever beams are not allowed. Then cantilever beams are not allowed. But in case of your simply supported beam or continuous beam, you can modify your span ratio. Okay, you can modify your ratio by multiplying it by 10 over span. Okay, so if this is correct, this cannot be correct. देखो ना यार, कॉमन सेंस से आप इसको पता लगा सकते हो. जैसे मैं आपसे बोल रहा हूं कि L over D is let's say A, length of the span, or you can say it effective width, it is nothing but this ratio A. So let me take the example of SSB, simply supported beam. So if it is simply supported beam, then it is going to be 20. It is going to be 20, my dear friend. But if my span is greater than, if my L is greater than 10 meter, in that case, just think of the common sense that in that case, if D is equal to L by 20, so if L is greater than 20, if L is greater than 10 meter, then what do you think? Will you be needing more amount of D or not? Yes, obviously. If length of the simply supported beam is greater than 10 meter, then huge amount of bending moment is going to generate, because bending moment is the function of length of the span. So if it is greater than 10 meter, then my dear friend, in that case, this depth of the cross section must be increased. then only the deflection criteria may come under the control. If deflection criteria को कंट्रोल में लेके आना है, in that case डी का वैल्यू बढ़ाना है, और डी का वैल्यू तभी बढ़ेगा जब ये 20 का वैल्यू कम होगा, और ये 20 का वैल्यू तब कम होगा जब आप इस 20 को 10 ओवर स्पैन से मल्टीप्लाई करोगे. देखो 10 तक तो 10 बाय 10 1, बट सपोज 15 मीटर का स्पैन लेके जा रहे हो, 20 मीटर का स्पैन लेके जा रहे हो, सो देन इंस्टेड ऑफ 20 you have to use only 10. So by doing that, ultimately you are increasing the value of D. Okay. So this is therefore statement number 1 is 100% right. Okay. Now next thing is, तो ये तो उल्टा तो करेंगे नहीं, so this is wrong. So they get further modified depending upon the area of and type of the tension reinforcement. Absolutely correct. ना पेज नंबर 35 में आई थिंक ग्राफ बना रखे हैं, 3 ग्राफ बना रखे हैं. एक बना रखा है डिपेंडिंग अपॉन द एरिया ऑफ टेंशन reinforcement, with the very next graph on next page is on the based on compression steel, और उसके बाद वाला दे रखा है आपको B by T रेशियो वाला, T सेक्शन वाला, फ्लैंज सेक्शन वाला. So this is also incorrect. It actually get changed with the help of by the taking care of the effect of compression steel. So this modification factor is done for span greater than 10 meter, but don't but be reminded that it is not valid for cantilever. Cantilever आपका 10 से कम ही IS कोड बोलता है, 10 से ऊपर वाला cantilever IS कोड मना करता है लगाने को. Okay, but in simply supported and continuous beam, it actually gets modified for greater than 10 meter. It is modified based on the percentage of reinforcement, tension reinforcement as well as compression reinforcement, but यहाँ पे do not लिखा है. That is why I am making this statement as incorrect. So A and C are right. A and C are right. So A and C are right. Question number 9. Majid is right. Well done, Majid. Okay. चलिए. Now the 10th question. Tenth question out of 14. सर पूरे YouTube पे रेलवे इंजीनियरिंग कोई भी अच्छे से नहीं पढ़ाया है, प्लीज इस पर लेक्चर लाइए. AY. ओके. रेलवे इंजीनियरिंग के ऊपर लेक्चर लाना, एक तो मैं पसंद नहीं करता हूँ रेलवे हाईवे ये पढ़ाना दोस्त, है ना. तो ये तो वैसे ही मेरे इंटरेस्टिंग टॉपिक नहीं है, तो मैं कैसे लाऊं इसके ऊपर. बट हाँ, अगर बनेगा कभी प्लान पढ़ाने का, देन डेफिनेटली आई विल टेक. ओके, जस्ट ए मिनट, लेट मी टेक. ओके, आफ्टर दिस क्वेश्चन आई विल टेक ए ब्रेक ऑफ 1 minute. ठीक है. The depth of isolated footing for a long column is governed by, my dear friends, tell me. Yes, Shiti sir is a teaching railway. You can watch his lecture. He is the excellent faculty in surveying and transportation, even RCC. You can watch his lecture, my dear friend, AY. Okay, the depth of the isolated footing for a long column is governed by, my dear friend. Generally, you can say, first of all, you are calculating depth on the bending moment, then you are modifying it for one-way shear, then you are modifying it for two-way shear. But I am not considering here the maximum bending moment, because in you can say footing, you are not providing a dedicated shear reinforcement. You are not providing a dedicated shear reinforcement. So entire design of shear is to be checked based on the thickness. So increasing thickness is only the criteria, is only the way to prevent my footing in shear. So that is why I am only going to keep shear components under the governing criteria. So option B and C both are correct. Option B and C both are correct, my dear friend. So अंकुर जी कह रहे हैं एबीसी. ओके, गवर्न बाय, है ना, तो वहां पे अब शेयर स्टेटस का प्रोविजन नहीं है ना आपके पास अंकुर, इसलिए बेंडिंग मोमेंट को आप यहां से एलिमिनेट कर सकते हैं. भारत इज ऑल्सो सेइंग एबीसी, अक्षर निशांत इज सेइंग ए एंड सी. ओके, but shear criteria are the correct one. I would like to go with B and C. I would like to go with B and C, है ना. कुछ लोग A पे भी डिबेट कर सकते हैं सर, why not A? A is there, है ना, बट गवर्न बाय का मतलब होता है जिसके हिसाब से चीजें चलें, है ना. बेंडिंग मोमेंट के तो एनी हाउ यू आर गोइंग टू प्रोवाइड, है ना. अगर यहाँ पे आपका शेयर रिइंफोर्समेंट, शेयर स्टेटस प्रोवाइड करने का प्रोविजन होता तो आप डेप्थ के लिए वहां भी नहीं सोचते यार. सी, सपोज, लिसन टू मी माय डियर फ्रेंड, suppose your depth of the footing is 300 mm, but if you want to make it 200 mm based on the bending moment, then you can use the high grade of concrete, or even you can use the high grade of steel. Okay, so by that you can control the depth of the beam, but you do not have any provision to provide shear status on the footing. So that is why it is very very important to pass the one way and two way shear criteria while deciding the depth of the isolated footing. यस माय डियर फ्रेंड, टू वे शेयर मतलब जो दोनों दिशाओं से आपका फेल हो जाए, इट इज सिंपली योर पंचिंग शेयर. सी, दिस इज वन वे शेयरिंग एंड it is your two way shearing, and the critical section for one way shearing is located at a distance of D. Critical section for two way shear is located at a distance of D by 2 and D by 2. And the critical section for bending moment is located at the face of the column, at the face of the column. Okay, yes, so punching shear and two way shear are same. Yes, so this red one is two way shear. ओके, यस, सेम रहेगा, शॉर्ट कॉलम के लिए भी सेम रहेगा शिवम. ओके, बट देखो होता क्या है ना, शॉर्ट कॉलम के अंदर लोड कम आता है. शॉर्ट कॉलम के अंदर अगर लोड कम आएगा, सो बेस्ड ऑन दैट शॉर्ट कॉलम के ऊपर अगर लोड कम आएगा, सो बेस्ड ऑन दैट माय डियर फ्रेंड, अमाउंट ऑफ shear force would be less there. Okay, ठीक है सर. एक क्विक डाट, हाउ वी डिसाइड द थिकनेस ऑफ द पेडिस्टल. अब पेडिस्टल का थिकनेस कैसे डिसाइड करना है, एक्चुअली पेडिस्टल डिजाइन करवाया नहीं है मैंने अभी किसी को, मैंने लेक्चर भी नहीं लिया इसके ऊपर कोई. ठीक है, आई विल चेक ऑन दिस एंड लेट यू नो. पेडिस्टल का थिकनेस का क्राइटेरिया भी हमने डिजाइन किया नहीं है उसका, सिर्फ आइसोलेटेड फुटिंग मैं करवाता हूं because that is the only requirement here. So pedestal I have never designed, but I can give you the confirmation on that. Okay, okay, ठीक है, ठीक है. Next is question number 11 of 14. This is again from strength of material. For a given figure below shows a shear force diagram of the beam ABCD. Which of the following are correct? Okay. Let me tell you one thing. ABCD. This is L by 4. This is L by 2. This is L by 4. Okay. So AB is L by 4, CD is L by 4, and it is L by 2. And this ordinate are same. This ordinate and this ordinate are magnitude wise same. Okay. हाँ शशि भाई हमारे कोई सजेशन दे रहे हैं. I think it is for Ajay that one tan alpha formula is there. Okay. So question 11. Question 11 लिख दिया मैंने. Okay, okay. I have already written there. Ajay is saying I have not seen WSM is not given. Pedestal design आपका LSM से नहीं दे रखा, WSM से ही है. Only serviceability criteria. Only serviceability criteria. Okay. BD, BD, ABD. Okay. ABD, ABD. क्या बात है, क्या बात है. Okay. Well done, guys. Most of you are correct. The correct option is A, B, and D. Yes. See, if I am going to draw, you can say the corresponding beam for this pattern, then it may be like this. There would be a beam simply supported. Shear force is constant from here to here. So it is your A, B, C, and D. So one load is assigned here. कुछ भी ले लो. One load is assigned here. So it is P and it is also P. Okay. So this is L by 2, L by 4, L by 4. So reaction would also be P and P. And you can see PL, P, P into L by 4. From here to here it is P into L by 4. Then again PL by 4 to 0 linearly. So you can say bending moment is non-zero constant for C. सही बात है. BC span पे bending moment कितना होगा? It would be somewhere like this. Non-zero constant. Bending moment is same at B and C. Absolutely correct. Bending moment is parabolic from A to B and D to C. No, incorrect. It is a straight line. Bending moment is linear from A to B and D to C. वैसे C और D में से कोई एक ही ठीक होना था. ठीक है. Is it clear? चलिए. So A, B, D, all three are correct. Well done, guys. Well done. Good. Yes, pure bending concept questions. Okay. Now, my dear friend, here is question number 12 on your screen. Okay. So, my dear friend, it is a good question. Try to answer it. मजा आएगा. And let me take a 2-minute break here. 2 मिनट ब्रेक लेता हूं मैं यहाँ पे. पानी वानी पी लूं जरा मैं भी. Okay. लग जाएगा आपको. Minimum 2 minutes, minimum 3-4 minute question is there. But I'm coming back in 2 minutes. Okay. So Muhammad Majid is saying, sir, B, C, D is right. Only one answer so far. Only one answer so far. Ajay is saying A, B, C, D. Means all four are correct. अजय मैक्सिमम डिफ्लेक्शन तो बी पे ही आएगा यार. मैक्सिमम डिफ्लेक्शन विल कम एट बी ओनली. Okay, see what you can do here. Listen, this is internal hinge roller. Okay, so you can break this diagram structure at B. If you are breaking it at B, between A and B बोला है ना, between A and B बोला है आपको. So between मतलब and points are not considered. And points are not considered here. Okay. So it is somewhat like this. A and it is B. It is also B and it is C. Okay. So ये आ गया P मेरे पास 3A. ये आ गया मेरे पास 2A और यहाँ पे रिएक्शन था आपका कितना P और ये नीचे वाला बीम इसके ऊपर कुछ ना कुछ रिएक्शन दे रहा होगा. Let's that reaction be R. So same reaction would be applied here. This is also R. So now we know that in reality deflection at B is going to be same. In reality deflection at B is going to be same. Isn't it? Okay. No. Maximum deflection over the structure that would be here only at B only. Because if you are going to draw its elastic curve, then it would have its tentative shape like this. ये कुछ ऐसा बनेगा ना. Zero slope here, it would be maximum. Then two slopes at B and again it will be going like this. So कुछ ऐसा बनेगा ये. Okay. Yes. So here you can compare the deflection at B. That is going to be same because they are the part of same beam only. So deflection at B in the left beam is P minus R L cube upon 3EI and it is R A cube upon 3EI. Okay. So this and this will get cancelled. तो आप यहाँ पे a cube हटा दो तो बचेगा P minus R into 27 9 या 27 is equal to 8 times of R. So 27 or 8 35. So 35 R is equal to 27 P. So R is known to you. ये दिखाई दे रहा है आपको? Boundaries are not here. So R is equal to 27 P by 35. 27 P by 35. बट यहाँ पे तो कुछ बात ही नहीं कर रखी. हाँ, A पे बेंडिंग मोमेंट निकाल सकते हो. A पे बेंडिंग मोमेंट कितना हो जाएगा? So now this is 27 P by 35. This is as well 27 P by 35. So what is this? This is P minus R is how much? It is P minus 27 by P, the 27 by 35, so it is going to be 8P by 35. So 8P by 35 into 3 is 24 PA upon 35. So this is correct. This is correct. And what about shear force at left of B? Shear force at left of B is equal to P minus B, which is 8P by 35. And shear force अगर राइट पे पूछा होता तो कितना होता? 27P by 35. This is correct. Now what about deflection at B? So deflection at B, my dear friend, you can find it from here. So it is P L cube 2A cube, so 8A cube upon 3EI. So ये हो जाएगा कितना? 3 नीम 27. तो 8 नीम 72, 72 PA cube upon 35 EI. 72 PA cube upon 35 EI. Is it clear? Is it clear to all my dear friend? Okay. So I think this is also justified. Option B is also correct. Okay. So B, C, D, all these three options are right options here, my dear friend. Okay. So good attempt, my dear friends. Muhammad Majid is the one who has given it correct. Okay. Ajay was also very, very close. So now the second last question of this session, my dear friend. And this is from pre-stress concrete. So second last question from RCC. ये theoretical है. अच्छा, आज मैंने क्या किया है? आज मैंने आरसीसी के थ्योरेटिकल क्वेश्चन डाले हैं और स्ट्रेंथ ऑफ मटेरियल से न्यूमेरिकल लेके आया हूं, है ना. नेक्स्ट वीक जो मैं सेशन लूंगा उसमें मैं आरसीसी के न्यूमेरिकल ज्यादा रखूंगा, थ्योरी कम रखूंगा और सॉम में अपना थ्योरी थोड़ा ज्यादा रखूंगा. सो लाइक दैट आई एम गोइंग टू मैनेज योर नेक्स्ट टेस्ट. और यू कैन ऑल्सो गिव मी योर जेन्युइन ओपिनियन दैट व्हाट शुड you can give me the feedback of the session. If you think that we need to change something, then we will be changing it. Okay. तो आप अपना genuine feedback दे सकते हो इसी सेशन में, बता सकते हो कि how to set the level of the question. Okay. जल्दी बताओ तो आसान है. फास्ट, जल्दी सब लोग. Okay. Shivam is saying A, B, D. Ajay is saying A, B, C, D. My dear friend, ये याद ही कर लो. All these are the ways of pre-stressing. Pre-stressing hydraulic jack से भी होती है, थर्मल मेथड से भी होती है, सपोर्ट को हिलाकर भी होती है और एक्सपेंडिंग सीमेंट का यूज करते हुए भी होती है. So all of four options are correct, है ना. All these four options are correct. Yes. So Ajay Khatri is right. चलिए. Now the last question of the session, my dear friend. 14 by 14. It is again from the strength of material. So the probed, this is A, this is let's say B and this is C. Let's say the center as, ऐसा कर लेते हैं, इसको C बोल देते हैं, इसको D बोल देते हैं, है ना. It is in 2 dimension. It is in 2 dimension. AC is like this and BD is like this. AC, BD. This end is fixed and B and D are simple supported. Okay. तो ऐसा ले लो. ऐसा ले लो. ये हो गया आपका फिक्स बीम, ये फिक्स बीम हो गया, और ये रखा हुआ है सिंपल सपोर्ट बीम के ऊपर. So this is simple support. My this middle finger and this thumb are simple support. So these are kept like this, and this is fixed support. Okay, like this. इसका लेंथ L है, इसका लेंथ L और L, तो टोटल लेंथ का 2L. So it is actually meeting at the center. Okay, it is actually meeting at the center. Is it clear now? ये सिंपल सपोर्ट मेरी उंगली और मेरा अंगूठा. ठीक है. So solve it. Question number 14. Question number 14. Okay, tell me. किंगराज ने जो आंसर दिया है, इज दैट फॉर 13 और 14? किंगराज, इज इट फॉर 13 और 14? टेल मी. ओके, सेम उसी कंसेप्ट से करेंगे जैसे मैंने आपको पहले बताया था. व्हाट आई एम गोइंग टू डू हियर एट सी जंक्शन, I can consider the reaction given by BD to AC, and the same action from AC will be given by to BD in the downward direction. Okay, so let me just make the free body diagram. Let me just make the free body diagram. So what is going to happen here? ACD. Okay, so ACD बोल रहे हैं. So P, this is L, P. Okay, and here you are getting R. Okay, ठीक है. A as well as B, A and C, and next is it is like this. ऐसे ही बना लेता हूँ, इसी के नीचे बना लेता हूँ. 2L है ना ये. So R would be acting here, और ये सपोर्ट्स हैं like this. Okay, so again you can consider here the deflection. So deflection at C here is simply P minus R L cube upon 3 EI. So deflection at C here would be R L cube upon 3 EI, or not 3I, sorry, 48 EI. WL cube upon 48 EI. So compare these. ये हो जाएगा 16, ये हो जाएगा 8 बटे 16 R/2. So P minus R is simply equal to R by 2. तो P हो जाएगा मेरे पास 3R/2, तो R हो जाएगा मेरे पास 2P/3. So this reaction is 2P/3. So this will also be equal to 2P/3. This will be equal to P/3 and P/3. Okay. So this is also P/3. So here the bending moment would be PL/3. और क्या पूछा है सब निकाल दो. Bending moment diagram would be like this, symmetrical. So the probe reaction at the center of the simple support given by the figure is 2P/3. Correct? It is given by the 2P/3. Support reaction at simple support is P/3. Correct? It is 2P/3. It is P/3 and P/3. SFD of simple supported beam is anti-symmetrical. इसका अगर आप SFD बनाओगे तो कैसा बनेगा? It would be like this. Yes, it is anti-symmetrical. And BMD is symmetrical. So all the four options are right, my dear friend. So Ajay Khatri is once again all right. Okay. किंग राज जी ने दिया था 13वें का आंसर. ओके माय डियर फ्रेंड. ठीक है. तो कोई डाउट हो तो किसी को पूछिए, कोई पूछिए डाउट. एंड माय डियर फ्रेंड, जस्ट गिव मी योर जेन्युइन फीडबैक अबाउट दिस सेशन. आई थिंक क्वेश्चन एक दो और हो सकते थे. क्वेश्चन से एक दो और हो सकते थे. एक तो मुझे ये लगा, बट मैंने 14 ही क्वेश्चन फ्रेम किए थे. ओके. सेशन को लाइक कर देना दोस्तों सब लोग एक बार. एंड ट्राई टू शेयर इट, है ना. मैक्सिमम लोगों तक पहुंचाइए इसे. दैट इज ओनली द मोटिवेशन ऑफ आवर्स ऑफ टेकिंग लेक्चर. ओके, चलिए. सो वेल डन गाइस, नाइस पार्टिसिपेशन. बट यस, पार्टिसिपेशन थोड़ा और बढ़ सकता है. तो यहीं तक रहने देते हैं आज. सेम सेशन MSQ MCQ करेंगे अगले हफ्ते. एंड आफ्टर एट 12:30 Mrigang sir is going to take your session on environmental engineering or CF, है ना. अच्छा सर, प्लीज 1-2 टफ क्वेश्चंस ऑफ ESC means as well. ओवरहैंगिंग का कॉन्ट्राफ्लेक्सर बताइए. ओवरहैंगिंग का कॉन्ट्राफ्लेक्सर माय डियर फ्रेंड अगेन इज गोइंग टू बी द फंक्शन ऑफ, यू कैन से, लोड. डिपेंड करता है कि लोड कहां पे लगा रहे हो, कैसा लगा रहे हो. लाइक दिस. इफ इट इज UDL देन इसका जो डायग्राम होगा, it can have all the three possibilities. It may be like this, possibility 1. It may be like this, possibility 2. Or it may be like this, possibility 3. So here it can have two contraflexors. Here no contraflexor, here no contraflexor. Okay. So it depends upon A and L ratio. ये आप निकालते भी हो SOM में कि what should be this ratio, isn't it? So you can calculate accordingly. You can calculate that accordingly. Okay. जो भी आता है आपका A/D ratio, L/4, L/3, वो you can calculate there. Okay. So it is a function of A and span ratio, my dear friend. Is it clear, Rahul? ना, चलिए. So my dear friends, let's keep our session here only. अच्छा, और कोई feedback? ओके अजय, नेक्स्ट टाइम देता हूँ, अच्छे क्वेश्चंस भी देता हूँ, है ना। ऑडियंस कहाँ आती है, अच्छे क्वेश्चन दो तो। बोलते हैं सर बेकार पढ़ाते हैं, क्वेश्चन नहीं होते, ऑडियंस आनी बंद हो जाती है। चलिए, so my dear friend, these are the some of the subjects taken by our pool at Unacademy Gate C: fluid mechanics, strength of material, RCC steel, RCC in Hindi, OCF geotech, irrigation structure, surveying, geotechnical engineering, environmental। ये geotechnical engineering का नया पोर्शन है, जो बाद में फ्रेशली ऐड हुआ है ना, वो वाला पोर्शन है। Hydrology, highway engineering, so all these are the, you can say, some of our playlist। एंड यस, जैसा कि मैंने आपको कहा था रिगार्डिंग सब्सक्रिप्शन, दैट फॉर प्लस सब्सक्रिप्शन माय डियर फ्रेंड, पहली बात तो मैं 1 ईयर और 2 ईयर प्रेफर करता हूँ, 18 मंथ, 1.5 साल का। मैं 3 महीने, 1 महीना, 6 महीने वाला सब्सक्रिप्शन मैं प्रेफर ही नहीं करता, तो उसका स्लाइड भी मैं नहीं लगाता। सो 1 ईयर वाला अगर आपको सब्सक्रिप्शन लेना है, देन यू हैव टू पे दिस। 18 months you have to pay this, 24 months you have to pay this, but these rates will only be displayed to you only after applying H10। H10 से पहले आप इसका कॉस्ट और बढ़ा लीजिए, 10% डिस्काउंट के बाद you have to pay this amount, okay। And similarly about iconic subscription, my dear friend, for 1 year subscription you have to pay 45,225। You have to pay here, my dear friend, 45,225। क्यों होता है महंगा, मैंने आपको बताया था ये, है ना। तो ओरिजिनल कॉस्ट इसका महंगा है, ओरिजिनल कॉस्ट इसका 50,000 समथिंग है, isn't it? So similarly it is also 74,000 है, but after applying S10 you have to pay for 2 years 66,600, okay। So these are the prices for iconic and plus subscription, दोनों ही वर्थ है ना। अगर आपको लगता है कि विदाउट एनी पर्सनल अटेंशन एंड ऑल यू कैन मेक योर प्लान, टेस्ट एनालिसिस यू कैन डन बाय योरसेल्फ, देन यू कैन बाय, यू कैन से प्लस, otherwise you should go for iconic। and you all can follow me at Unacademy, so @sharma_aishwarya1049। और ये है हमारा ऑफिशियल टेलीग्राम चैनल, जिसके अंदर हम आपके पास सारे लेक्चर्स के डिटेल्स एंड नोटिफिकेशन भेजते हैं। And all these are the study channels at Unacademy Gate CE, and right now you are watching me at this channel Unacademy Gate CE। So very thank you, my dear friend, stay safe, stay connected, don't go outside if it is not required, okay। So well done guys, उम्मीद करता हूं कि अगले सेशन से भी आप ऐसे ही रहोगे, पार्टिसिपेट करोगे, एंड टेक केयर, बाय बाय।